Today's lab is focused on your assignment, preparation for doing the assignment, early activities, and the methodology for conducting the assignment. In particular, I want to draw your attention to these parts of the project: selecting an appropriate data set, identifying suitable machine learning task or tasks, preparing and pre-processing the data. Also, the process of conducting a series of experiments, including the tuning of parameters. This is a methodology which I've developed and used with large numbers of students in the past. We're going to look at the workflow for developing an AI component. We're going to discuss measurement scales, and we're going to talk about replacing missing attribute values and outliers. Here's the basic workflow for developing an AI component. First of all, analyze the domain data. What is the data set we've got? What are its properties? And this will tell us what we can and should do with it. These are the things we're interested in: the size and complexity of the data set. This will affect how much training data we've got, and therefore the kind of partitioning between training and testing data that we will use in developing the component. Attribute scale types and attribute distributions together give us information about how to process missing attributes, what to replace them with. The attribute distributions and the method of measuring distributions, which comes from scale types, tells us what to do about outliers. When we've analysed our data set, decided on training and testing splits, and dealt with missing attributes and outliers, we can then proceed to the process of training, evaluating and testing our data set with these partitions of data that we've produced. The next step is to consider potential AI components that we could use. In this particular discussion in the past, I've suggested artificial neural networks, backpropagation, multilayer perceptron types, decision trees as the most likely candidates to start with. There are also other classifiers like the naive Bayes and so on that you could consider. Our general approach to research in this area has been to look at ANNs first and decision trees, evaluate how they perform with the data, and then consider some more specialized classifiers later if necessary. When we know what classifiers we're going to conduct experiments on to see about their suitability for the data, we need to establish some global learning parameters for the classifiers. These differ across the different classifiers. So with the neural networks, they are learning rate and momentum, which will be covered by Dave McLean in future lectures in this particular module, which will be covered by Dave McLean in this particular module. Decision trees, mainly we're looking at the pruning methods used to produce more compact and better generalization in the trees. And then each of the other components you might be interested in will have their own learning parameters. The point is that we need to optimize these parameters to optimize the learning process.